Welcome everybody. My name is Michael Hess from Battronics Engineering, and today we give you an overview of what we offer at Battronics. First of all, Battronics works on batteries and their associated electronics and is based in Zurich, Switzerland. So we offer three different services, and the first one is called Better Knowledge, where we basically summarize the existing knowledge on different chemistries and technologies that are incorporated in lithium-ion batteries. Then we help on our customers on implementing such technologies in their products and to create intellectual property on their specific chemistries or technologies. And last, we also do better research, where we actually research ourselves to overcome today's limitations of lithium-ion batteries. For example, here on cycling at cold temperatures, for example. All right, so let me first introduce you shortly to Better Knowledge. Here we summarize basically all the literature that is today and on lithium-ion batteries, and this literature is basically very gigantic. So it's we are having 400 papers and around 150 patents each month in the field of lithium-ion batteries and their implementation. And the problem is that such literature is often false or has significant errors inside, especially papers, for example. The knowledge between team members varies significantly, and a lot of money is actually invested in a company to basically keep up to date and know what's all the competitors do in the market. And what we offer here is summaries and workshop on specific topics. We directly mention the errors in the literature and basically delete them from there for our customers. We give the team a broad knowledge so that there's no big risk of implementation errors or communication problems within the team. And I brought here some examples of some of the topics we are covering. Basically, we work on liquid electrolytes, for example, the minimum and maximum temperature where you can operate in, and what happens actually if you work below or above such temperatures. Then the various different transport properties and additives that you can add to improve your battery cycling. We also work now on solid state and polymer electrolytes. Second topic is, for example, active materials. Here, graphite, then silicon graphite composites, and various different cathode materials like NMCs, like NMC 811 and so on. Lithium iron phosphate, NCA with very low cobalt content now, for example, that is introduced by Panasonic Tesla. Also on the periphery we work, battery management systems, separators, and so on, temperature control, and a little bit also on economics, but this is a much smaller segment. When we help our customers implementing new technologies or batteries into their custom-made applications, we can actually help here in our better consulting segment to actually avoid specific issues. So often internal resources are already occupied in big OEM companies, but often one needs immediate solutions to a specific problem one has in the field or in the market. And such problems are often interdisciplinary and have complex topics. For example, the engineering topic is combined with chemistry in the field of lithium-ion batteries, and then it becomes more tricky to solve. And here we jump in and immediately help solving this specific problem. You don't have long-time money allocation because you just hire us to solve your specific problem, and we rapidly progress towards the solution together. And here we have brought different examples, like for example on aging of batteries or the impedance rise that you observe during aging of batteries. If you do modeling, for example, with COMSOL, Newman models, or if you have your battery management system to parameterize and also on cooling systems and battery management systems we help. Not least, we also help doing research for our customers. And as we all know, research is very time consuming and long term. It's often not a direct operative field. For example, for automotive companies, you need to dive into chemistry fields inside of a battery to understand your operation of your system. And often companies have very high safety measures. So a lot of experiments are not allowed, for example. But one needs such knowledge and such research to have a competitive advantage to the other companies in the same market segment. And what we offer here is specific research for your needs on various different topics: charge rate, capacity, aging. You have significantly less risk due to outsourcing. And each one of us actually concentrates on the core business. And the exclusive patents are always only for our customers. So for you, basically. And here I brought a topic which is very important. For example, if you cycle your lithium-ion batteries, you basically form always a so-called solid electrode interface on a negative electrode, so on the graphite surface basically. And it's thought and always modeled in battery management system and in all kinds of models. It's usually assumed to be a linear ohmic resistor, so just the resistance. And then you measure impedance spectroscopy, like for example here on the upper right, you measure impedance spectroscopy. And you see various different resistance. For lithium ion, for example, 45 ohm, for sodium already 240 ohm, and for potassium already 3 kilo ohm resistance just from the SEI. And we found out that this SEI is actually highly nonlinear, so it's not an ohmic resistor. And you would basically, 3 kilo ohm in a battery would just mean it's a heat source, yeah? It's not a battery at all anymore. But of course, it's potassium ion batteries are not just a heat source, they are really working. So, and this is actually because this resistance is highly nonlinear. And impedance spectroscopy is actually quite useless to determine the SEI resistance. Although it's here correctly measured, it's not helpful to determine, to use this resistance now to parameterize your model. And we can help you, for example, implementing it. And one important topic is that this SEI resistance actually has a critical temperature, and below this temperature the SEI resistance increases very, very strongly. And so at low temperatures, basically below 5 degrees Celsius, you have a more and more risk of lithium plating and the safety issue in lithium-ion batteries. And this is very important for automotive companies, for example, if they operate their vehicle also at -10, -20 degrees Celsius and want to recharge their batteries. So here we directly help on transferring such knowledge that you gain on the lithium-ion batteries itself and transfer it to your application. Right. With this, I want to thank you, and I hope you liked the little company introduction of us, of Battronics Engineering. And if you like, you can contact us anytime. Thank you very much.